This is daily data where you can learn data science in 2 minutes a day. Let's get started. Today we will talk about the sample variance. So, like yesterday with the interquartile range, the sample variance is a measure of the spread of a set of data. Let's define it. It's the most natural one to consider if we take the mean as the center. Suppose our set of X data contains n data points, and it has a means which we used the Greek letter mu for. We can measure it by taking the distance of any point X from this mean, mu, and to make this positive, we will square it. If we do this for each value, add them up, then we take the mean of the result, we get sample variance of X, capital var X. That is, var X equals the sum of each element, X minus mu squared, and then this is divided by the number of elements, n. So let's have one example. Do you remember our very first data set at the beginning of Winter of Data? So if we have 3, 3, 3, 3, 4, 4, 4, 5, 9, then the mean is 4.2. To calculate the variance, we subtract the mean from each value. So in each case, we will have minus 1.2, minus 1.2, minus 1.2, minus 1.2, minus 0.2. This is very close to the mean. Minus 0.2, minus 0.2, 0.7, and 4.7. Now we square each of these, add them up, and divide by 9. To 3 decimal places, our variance will be 3.284. The standard deviation of X is actually the square root of var X. In this case, the square root of 3.284, which is 1.812 to 3 decimal places. You can also look at the expectation and variance of a probability distribution. So now you see we actually are getting into the meat of things, and this will be supremely useful. I am Ilona, second of my name, of the house 1 Million Women to Tech, and Winter of Data is on. Join us for free. We are a small nonprofit run in the Silicon Valley by 4 volunteers and many, many mothers of communities. Become a learner, become a mentor, mother of community at 1millionwomentotech.com. Thank you and see you tomorrow.